Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides even more practice performing hypothesis testing and constructing confidence interval estimates for two independent population means. Let's get started. So for this example, we're going to look at connections between IQ level and levels of lead in the blood. So it's been observed for many decades in the mental health community that higher concentrations of lead in the blood are associated with insanity. I mean, people with high levels of lead in the blood tend to go cuckoo. They lose it. They lose their marbles. They become certifiable. So it's an interesting claim that we have here. The claim we're testing is that the level of lead in the blood has no effect on the mean IQ score. Now, not necessarily true that, people who are crazy are stupid or not intelligent. I mean, there are plenty of examples in the field of, literature and film that are based on real life examples where, you've got people who are criminally insane. They're criminal masterminds, but they're certifiable at the same time. And so, it's an interesting claim that we're looking at here. Anywho, you've got your sample stats there in the lower right corner of the screen. Notice that the low lead level group is the first sample because we have the subscript 1 with those sample stats. The high lead level group is going to be sample 2. We have the same stock standard questions that were typically asked about these sorts of things. And we're testing at the 5% significance level. So let's get into it. The first question we have is about our hypotheses. And we know that to construct the hypotheses, the first thing we're going to do is think about the claim. So what's the claim that's being made here? Well, the claim is that the lead level in the blood has no effect on the mean IQ score. So that means that the mean values for each of those samples, or populations rather, are going to be equal to each other. There's no difference, they're the same. We could write that alternatively as mu1 minus mu2 equals 0. The null hypothesis, by definition, is a statement of equality. So we can write that out. The difference in our mean values is equal to 0. And notice that this is the actual claim itself. So we can't actually adopt that as the alternative hypothesis. So we're going to have to take the complement of our claim as the alternative hypothesis. And the complement of being equal to is being not equal to. So here we have our null and our alternative hypotheses. Now this creates a mismatch between our claim and our alternative hypothesis. That becomes really important when we go to look at constructing the appropriate confidence level estimate. And we'll get to that later in this mini lecture. But for right now, for terms of the hypothesis test, all we need is that inequality sign in the alternative hypothesis. It's not equal to, therefore, we know that we have a two-tailed hypothesis test. The test statistic, we're going to get out of StatCrunch. So go to Stat, T-Stats, to-sample with summary. And in the options window that appears, make sure again, after you put your sample stats in, that box for pool variances is unchecked. The default radio button selection is for hypothesis tests, so just make sure your values represent. Typically, this claimed value here is going to be 0, and then make sure this inequality sign matches your alternative hypothesis. And once you get that, then you just press compute, and your test statistic you can read right off the results window. It's going to be that second to last, the next to last value there in the results window table. The p-value, if you're asked for the p-value, just take the last value that's listed there in that results window table. It will always be in that position. Will we reject or fail to reject the null hypothesis? Well, let's find out. We have everything we need to do that. The criteria is the same as we've always seen it. If we're outside the region of rejection, we fail to reject the null hypothesis. Inside the region of rejection, we're going to reject the null hypothesis. So back to the results that we had previously. If we use the p-value, we're going to compare that with a significance level of 5%. 0.0264 is less than 0.05. Therefore, we can fit inside the region of rejection, and therefore we're going to reject the null hypothesis. Alternatively, if we were to use that test statistic, we need to compare it with the critical values. The critical values are the boundaries for the critical region. And the critical region is simply that region in the tails of the distribution that has the same area as the significance level, 5%. So we've got half of it on the left and half of it on the right because we have a two-tailed test. That means we have two critical values. The test statistic you see here, the 2.28, that's going to be over here on the right. So we're inside that right tail, which means we're in the region of rejection, and therefore we're going to reject the null hypothesis. So either way you work it, come out with the same answer. What you conclude from the hypothesis test? Well, take what we've learned so far and select your answer. What do you think it is? A, B, C, or D? What say you? I'll give you a few seconds to decide for yourself what you want to answer. And I hope you selected answer option D, because this is the one that we want. Let's take a look at where each part of this answer actually comes from. So the first part, there is sufficient evidence. We say that because we rejected the null hypothesis. Next, we have a two-tailed test, so we're going to warrant rejection of the claim. And then the rest of the statement itself is just a restatement of the claim itself. Finally, we're asked about the appropriate confidence interval. Notice they don't give you the confidence level. They're trying to test your knowledge of this. And a particular example like this actually frustrates a lot of students because typically what we've seen up till now is that because we have two samples, the confidence level is going to be 1 minus 2 alpha. And typically that would hold true. But when we go to get our options window in StatCrunch, and flip that radio button over to the confidence interval, notice the confidence level down there. It's not 1 minus 2 alpha, that's 1 minus alpha. Well, what's going on here? Well, we actually reverted back to 1 minus alpha because there was a mismatch between the claim and the alternative hypothesis. So because of that mismatch, we go back, we're actually flipping back over just like we do when there's a semblance of equality with the claim itself. We have to take the complement. Same sort of idea here. We've got to switch things up a little bit because of the mismatch. So we go back to saying 1 minus alpha is our confidence level. So alpha here is 5%. That means our confidence level will be 95%. Again, because of the mismatch between the claim and the alternative hypothesis. We press compute, and out comes our results. We take our lower and upper limits right there from the end of our results window table. There's our appropriate confidence interval. What do you conclude from these results? Well, is 0 inside or outside the confidence interval? 0 is outside the confidence interval. So that means there is a difference in the mean IQ score between the groups. Furthermore, because all the values are positive, so 0 is on the left of our confidence interval, that means that mu1 will always be greater than mu2. And that mu1, remember, was the IQ score for the low lead level group. So lower levels of lead in the blood are associated with the higher IQ score. And that's pretty much the same thing we got out of the formal hypothesis testing method, is that, there's sufficient evidence to reject the claim that lead levels in the blood don't affect the IQ scores. Because they do affect the IQ scores, so we're going to reject that claim that they don't have an effect. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.